test run. Whoa. Turn up the amps. Turn up the voltage. Turn it down closer to 2, I guess. Very good. And then
I'm gonna give it a small push.
Let's turn up the amp just a bit. And turn up the voltage.
The speed increases as we turn off the voltage too, as it should.
So we're going to slow it down, turn it off essentially. Yeah, good. Now keep filming, keep filming.
Yep.
And then we're going to turn it back on. And give it a little push. Increasing the voltage in the amps. Voila.
We're gonna turn it off.
And we turn it off and cut the video. Alright, so this is our motor. Come on in. So for the design of our motor, we chose 2 armatures. Each one is wounded to 200 count, so 200 windings on each one. And we chose a steel bolt for the magnetic properties so that when it's energized, the magnetic field is amplified. Both the armatures and both the windings are then connected and soldered to each commutator. And we chose copper plate as our commutator material as it's very conductive and it was cheap and available at the time. So we just bent the copper plate into a relatively cylindrical shape to allow for optimal contact. And so going into our brushes, hi, cameraman, the check's already made out to you. So our brushes are also made of copper, as you can see, and they're lightly touching the surface of the commutator to allow the voltage and the current to jump and create the magnetic field. So if we come to the side right here, you see that this is where we're going to hold our magnets. Right now our test magnets are in there right now, but you can see they're smaller than the hole size because these holes are made for the competition magnets, which are significantly larger. So when we compete on Thursday, that is when we'll just slap the magnets in the holes and we're good to go. The stand also has a relatively simple shaft design or shaft holding design. Originally we had a bearing in each of these slots, but we decided to just have metal and plastic for simplicity and to not have to try and press fit anything for testing purposes when we're constantly swapping stuff out. And I believe that is everything for this design. You know, the bases, we 3D printed the base, we 3D printed the rotor, cheap copper plate, magnet wire with bolts. Pretty simple design, pretty unique. We like it. It does require a little push to get going, but in the end, it ended up working.